Welcome back to our series on polymers in our daily lives, where we focus on polymers that keep us safe or enhance our well being. In our earlier video, we discussed polymers and biomaterials, or polymers that interact with biology in many different ways.
Here we're going to talk about a specific type of polymer biomaterial, specifically polymer-based materials using dental fillings.
And of course, nobody likes a visit to the dentist, but dental health is an important part of our overall self care.
Right. And I think some of our viewers will have had at least one or two dental fillings or restorations. And we want to get a bit of info into the science behind these dental materials.
But polymers are not the only type of material used in dental fillings, correct?
Right. There are a few other different types of materials used in dental fillings, such as gold crowns and amalgam fillings. But there are some issues with those materials.
Yes, although gold is inert, it's also quite expensive. And in comparison, amalgam contains mercury. And additionally, both of these materials have colors that do not match the natural color of teeth, which is cosmetically unappealing. So, ceramics and porcelains can also be used. And these ceramic based dental materials really have the advantage of being color matched to the tooth, being strong, and really having a long lifetime.
Yeah, so what's the issue with these ceramics-based restorations?
Well, the main issue is that in many cases, the ceramic restoration must be made off site at a specialized facility. So, this means it can take a week or two to install the final dental restoration, and that's going to mean that two dental visits are often needed. Newer technologies, though, have reduced the time necessary to make that restoration.
Right. So I guess the question is, how do polymers come into play here?
And that's a great question. In general, polymers are used in dental fillings as a polymer composite. The meaning here is that the polymer is mixed with other components, such as hard silica beads, to create an overall strong material.
Right. And so why would people want a polymer composite-based dental filling?
Well, the main advantage of the polymer based restoration is that the filling can be placed in the tooth during a single visit, typically within a matter of minutes. The restoration has a reasonable lifetime of at least a few years, and the color can be perfectly matched to the existing tooth. The materials also avoid heavy metals, which can be found in gold and amalgam, which is a concern to some people.
Right. I guess the downside is that polymer-based restorations, tend to have a bit of a shorter lifetime, typically 10 years or shorter before they often need to be replaced. The main reasons for failure are secondary cavities or fractures to the actual filling itself.
Are there other problems with polymer based fillings?
Yeah, it's a good question. So there's one other, potential issue, which is due to stresses or internal forces in the material, which occur after the filling is applied. The idea is that polymerization takes, smaller molecules and makes a bulk polymer material out of it directly on the tooth. And so when you turn those smaller molecules into the bigger polymer, the overall volume of a system contracts a bit. And that can lead to a small mismatch between the ideal volume of that restoration and the current volume of material.
That's really interesting. So, where is this polymerization induced stress?
Right, so this stress is mostly in the filling and also at the place where the tooth meets the filling. In the worst case scenario, the stress can be so large that the restoration can actually separate off from the tooth.
Okay, so let's get into the exact process and really the composition of these polymer based dental materials.
Right. So the overall restoration is a composite material, which really means that it contains multiple distinct components, with each component giving a unique property to the overall material.
So, what are the key components in this dental composite?
Right. So there's one part of it which is a hard filler or a reinforcement, and these are typically or commonly made of silica, which is actually the same material as many sands. It's just at a much smaller scale. There's also a polymer which sort of binds into sort of a overall structure and holds the reinforcements together into the overall material.
So, how small are these silica reinforcements?
Yeah, that's a good question. So the typical size for these sort of silica reinforcements is in the order of about 10 to 100 nanometers. But some use mixtures of these sorts of nanoscale reinforcements and some microscale particles. And just for perspective, the human hair is about 50 to 100,000 nanometers in diameter. So the smallest particles are really, really tiny, about 1,000 times smaller than the diameter of a typical human hair.
Indeed is really small.
Yeah. So what about the polymer? What is it made of, and what are the structure of the polymers?
Well, the traditional polymer is made of relatively large organic monomers. The traditional combination being bis GMA, which is shown here in pink, and TGMA, shown in blue. These are polymerized by reacting the vinyl groups, and these are used to make a polymer mesh at the molecular level, which then holds the silica particles in place. So, in that case, the silica particles give the strength and the hardness, while the polymer forms a tough material that can actually hold its shape over time.
Right. But if a polymer keeps its shape, couldn't it be molded on the that? But if a polymer keeps its shape, couldn't it be molded on the tooth? How do we get around this problem?
Well, the trick here is that we start with the monomers that are not cured, combined with the silica particles, and this actually gives us material that can still flow and still be molded to the tooth. And then once it's molded, then we actually start the polymerization.
So how exactly do people go about starting this polymerization? You know, so that it's ready when the restoration is ready to be set, but not before.
Well, that's a great question. And here, typically light-driven reactions are used. So what we do is we use an intense but still mild blue light, and this is actually what starts the polymerization. And in fact, some of our viewers may have seen these blue light sources before during a visit to the dentist. And so this process goes through a what's called a radical polymerization pathway, where the energy of the light is used to generate free radicals. These free radicals then rapidly react with the vinyl groups in the monomers.
So what are the molecules used to generate these radicals?
Well, the main molecule that is responsible for forming the radicals is what's called camphor quinone, shown here in green. However, to make the reaction go faster, which means that this filling is able to be cured and completed in a shorter amount of time, nitrogen containing compounds such as amines, for example, the one shown in red, are actually added to the material. So the light actually controls when and where the reaction is happening. And because the dentists only use blue light, we don't need to worry so much about harmful radiation since the light that they're using is a part of the visible spectrum as opposed to UV light.
Yeah, the other property is that these radicals are generally pretty short-lived with timescales of about seconds. So the reaction stops pretty soon after the light is turned off.
So this is really interesting stuff. But what are some of the innovations that are going on in the field?
Right. So we sort of mentioned earlier this polymerization-induced stress is still a bit of a concern. And so to make the restoration have a longer lifetime, adaptable systems are being developed, right? So these are systems that release stress through sort of the polymer molecules shuffling around at the molecular level. So these sort of covalent adaptable systems are sort of a really cool innovation.
That is cool. That really sounds like a good way of resolving that sort of issue with those stresses.
Right. And the early data is really, really promising with regards to these materials' performance. So even though the actual polymer dental resins are decades old technologies, there's still a fair bit of room to innovate.
That's really cool stuff there. Well, looking forward to seeing these innovations as they roll out. And for now, we'd like to thank our viewers for tuning in to our video here on polymer dental fillings. We hope that they've all enjoyed this contribution. And next up in our video series, we'll be covering adhesives and the body. Thanks. Bye, everyone.
Bye bye.